Hey, what's up? This is Doug with Design 8 Studio. In our last video, we brought you part 1 of some preparatory work for using the LowRider 3 CNC to cut the parts for a torsion box, the ribs and the spars, in order to make a new, better CNC table. So here I have a CNC making a table for itself. You just saw me putting in screws to hold down this full sheet of 3/4 inch thick plywood. And now I'm changing the bit out in the Makita router, which is going to be carried around by my LowRider 3 mostly printed CNC. So the last step before cutting out the parts is to home the bit down to the top of the plywood so that it knows the right depth to cut. And then next up after that, enjoy watching the LowRider version 3 mostly printed CNC cutting out the parts of the torsion box. The playback speed here is 8 times normal. The torsion box's X ribs and Y spars are in this design 3 5/8 inches tall, which means that I can cut out all of them for the entire torsion box out of a single full sheet of 3/4 inch plywood. I won't keep you in suspense on where we're headed. Let me show you a screenshot of Estlcam showing how all of the Y spars at the top and all of the X ribs at the bottom are laid out. And I'm leaving my tool crib up so that you can see my settings. In particular, the tool in focus is the 1/4 inch end mill settings for plywood. We still have a lot of ground to cover in showing you the assembly and getting this new CNC cut torsion box table completed. So I'll go ahead and set the playback speed back up to 10x, and we'll march on through the rest of the cutting, and then I'll show you the assembly and the various bits of work necessary to get this not only built but set up and functional for using as a CNC table. And you know what? Let's not do 10x. Let's do 100x. Okay, so the profile cuts are now complete, and it went off without a hitch, and I'm thrilled. You'll notice that there's an unused corner near us on this full sheet of plywood, and my third and final cut, which I'll begin in a moment, is to put straight edges onto the side of this unused portion, making it easier to store and easier to use. And I actually start that cleanup cut pass while I'm still working to get the rest of the hold down tabs cut and to get the pieces out. You'll see there that in order to home down to the material, I had to put a couple of the X ribs back in place just long enough to home down to them so that I could then begin the cleanup cut operation that you see happening now. So it's just cutting right now a big L-shaped, kind of a sideways L to put straight edges on that unused portion. And while it's working on that, I continue on with retrieving pieces out of the finished profile cuts, taking some screws out, and getting ready to continue on with the project. These two holes in this X rib were pre-drilled by the CNC cut job. But I do need to manually drill inside the Y spar on each. Also, you may have noticed this, but there's a little lip cut right here on each of the X ribs, and the edge of that lip tells where the 49-inch MDF top skin should go. Also, there's an angle change down here, and that tells where the edge of the MDF bottom skin should go. All right, I think at this point I'm going to put glue on for each place where this first Y spar intersects with each of the 7 X ribs, and I will prepare a mixture of screws in the end and either clamps or weights to hold this Y spar in place while the glue sets, and I'll get a square out to check the angle for square at each intersection with one of the X ribs. Okay, so now I've just got to repeat that for 3 more Y spars. This design allows for the bottom to be narrower than the top, and the normal plan calls for MDF. There are 2 offcut strips that come away from the MDF, which are designed to be used as backer board for a support structure for the metal rails. And I had some OSB lying around and decided to use it instead of MDF. And I forgot at that moment that the MDF comes in a 49-inch width, whereas the OSB comes in a 48-inch width. So this means that after I cut off the 2 strips to serve as backer board for the metal strips, it left the remaining OSB a little bit too narrow. But this is not a huge problem. It only meant that on the 2 outside Y spars, instead of the screws going straight through into those spars, I needed to pre-drill at an angle and put those screws in at an angle over into the body of those outside Y spars. And that worked just fine. A circular saw with something straight clamped to the board, or one of these Craig straight cut pieces, really works good. About as good as a track saw, really, I think. You can see here that I retrofitted my really old Skill Saw Classic, which was normally a dust ejecting saw, and I retrofitted it with a little bit of work and some 3D printed parts that I designed to turn it into a dust collecting saw. No saw with an open side like this is going to be able to capture all the dust, but any sawdust that would have been ejected from the saw's back dust chute is being captured by the shop vac when I operate it in this way, and it does ease the cleanup quite a bit. Whenever I use the shop vac to clean sawdust off my own shirt, I have flashbacks of John Candy using a vacuum hose to clean food off of his own shirt. I bought enough of this Craig AccuCut straight edge for cutting to have a piece for 8-foot long sheets and another piece for making 4-foot wide cuts. And I have storage. I have some 3D printed AccuCut holding hooks on the side of my table that you see here for holding that long one. I'm sure some of you watching are wondering, if I already have a table for making CNC cuts, why am I making another one? And I want to explain that in a couple of ways. One is, we always build to the best of our ability at the time. And the amount of both tools and skill that I have now is better than the tools and the skill that I had when I first made the table that you just saw me use to cut out these torsion box ribs and spars. The table that you see me using from before is a table made by hand that's comprised of 2 torsion boxes that are made inspired by the Ron Paulk workbench style of torsion boxes, and then they are bolted together and then attached with screws to a base that I made. And due to whatever reason, sagging, some warp, twist, or whatever, they are not flat and not a good working plane. So if they're so not good, you may wonder, how is it that I can actually succeed in getting these parts cut? And The reason for that is that there is a huge difference in the flatness requirement for through cuts versus the flatness requirement for, say, V-bit engraving or any type of engraving work that doesn't involve through cuts. With through cuts, you can overcompensate. You can tell the machine to cut way deeper than the actual thickness of the material, leaving in some places deep gouges in your spoil board, and perhaps at other places no gouges at all. And so this is why, if you'll notice from the beginning of this video when I showed the attributes of the cut job that I was doing, I told the machine to cut at a 20 millimeter depth, which is deeper than the actual thickness of the 3/4 inch plywood. And in some places that barely was enough to get through, and in other places left deep gouges in my spool board. This means that while I could accomplish the through cuts, I would not necessarily be able to accomplish V-bit engraving or other work that requires more flatness. Here you can see me working to measure the diagonals to make sure that my box is square, and also to make sure that the OSB itself is square. And I realized that the OSB is not square, and this is typical that the factory edges, especially the 4-foot edges on plywood and OSB, are not square. And so because I have a little bit of length to spare, I decided to go ahead and try to get a more square edge and go ahead and cut off the amount needed to get this OSB more square on its ends. You've probably heard the faithful admission that mistakes were made. Inevitably, on a project this complicated, some mistake will happen. I'm just now realizing that I made a mistake in one of the X ribs being put on backwards. Thankfully, it was the one on the end. The orientation matters because the X minimum side of the X rib is a different length of extension from the side of the box than the X maximum side. So luckily, I was able to break the fresh glue loose, take the X rib off, flip it around, clean off a little bit of broken off wood that where the glue didn't want to give way, and then apply new glue and reseat and rescrew the X-rib back in place, this time with the proper orientation. It is tempting to keep these mistakes out of the video, but I wanted to go ahead and include this mistake just simply as a reminder to anyone following in these footsteps to be sure to check the orientation of the X-ribs. They are unidirectional, not bidirectional, and there's a right way they go in and a wrong way, so be sure to check them. In case you're wondering why a CNC cut table for a LowRider needs to have one side longer than the other, it has to do with the mechanics of how a LowRider works, and the design for ruthless efficiency has a call for more of an extension on one side than the other. just one of the rib to spar pairings needed pulled over slightly before putting the screws in, so I used this parallel clamp to hold it while I took care of that. So now I have my bottom attached, and again, this time I'm using OSB instead of MDF, and you can go either way, but I've got my OSB attached to both the X ribs and Y spars with screws. I do want to reiterate what I mentioned before, and that is that the length of the stick out on the sides with the X ribs is different on each side, and so you need to have them all oriented the same. The X maximum side has the shorter stick out, and the X minimum side has the longer stick out, and that's assuming you're using the standard orientation of Ryan's original LowRider. You want them all lined up so that when you look down them like this, they all are the same length on each side. So now I'm ready to attach a full sheet of 1/2 inch thick MDF for my top skin on the torsion box. And then on top of that, another 1/2 inch sheet, full sheet of MDF for my spoil board. Okay, so using this laser level, this is a Westco laser level. I'll put a link in the description. And I'm using it just sitting on the table that my torsion box is resting on. And I'm not leveling the table because a table needs to be level in order to do CNC cutting. I'm leveling it because getting it level gives me a frame of reference for checking it for flatness. And so I've got it in a mode that sends out a horizontal plane, and I've got it switched to its auto leveling mode. And you can see here the laser line is just below the 1 inch mark. And if I move this to a different place, it's just below the 1 inch mark. And if I move it all the way, and by the way, I had to shim the table, and I found that cardstock, in this case cardstock from the cereal box, stacks of cardstock and stacks of junk mail make good shims. But here you can see the laser line is just below 1 inch. And if I take it to that far corner just below the 1 inch mark, if I take it to that far corner just below the 1 inch mark, and currently anywhere I take it on the table, it's just below that 1 inch mark. So in this regard, even though a table needs to be trammed to the cutter, not necessarily level, getting it level allows me to easily use this laser to check it for flatness. So I've got the bottom skin attached, and I've shimmed it to get it level so that I can check it for flatness. And in checking it for flatness, I seem to be succeeding. So I'm going to go ahead and put the MDF top skin on, check it again, and then put my MDF spoil board on. And at that point, I won't be able to check until after I do a surfacing of the spoil board, because the last time it was surfaced was on a completely different setup. Okay, so now I have the top skin resting, but it only has one screw in it for now. But I just want to show you, there is a lip on the CNC cut X rib. There's a little lip that rises up, and that is intended to show you where the edge of a 49-inch wide sheet of MDF would come to. And when I put the MDF onto the torsion box, its added weight was enough that I needed to put shims in the middle on either side in order to get to keep flatness all across it. And right now, all places on the MDF sheet are measuring by the laser, where you see that mark there. And once I got that flatness demonstrated across the MDF on top of the shimmed torsion box, then I went ahead and put a screw down into each corner through the shim, tying the box down to the old table. And as far as placement goes, you can see that the edge of my X ribs are going to, there's going to be a piece of wood up against this, that the metal rail is going to sit on this lip and be bolted to this piece of wood. But you can see the placement is such that my metal rails will be almost exactly as far apart on the new table as they were on the old. And as far as placement in the long direction goes, I just happen to have had markings on the old table, and when I get right smack over top of this, you can see that my placement in the long axis is almost exactly where it was previously. I'm ready to go ahead and put some screws into this top skin to get it bound to the torsion box to give resistance against sagging. So to screw this top skin, which is going to rest under the spoil board, to screw it to the torsion box, I'll start off with attaching the top skin to the X ribs. Later, I'll go and put screws in line with the Y spars, and there'll be a line of screws attaching the top skin to the Y spars. In order to make sure that the screws sit flush, I first use a 3/8 bit to drill out a little countersink area, and then I use a 7/64 bit, which is this little thin one here, to drop a hole down through the countersunk area and down into the plywood of the X rib. And I countersink down a row, and then I use the small bit down a row, and then I use just a drill that has a torque selection to make sure that I don't over torque it, to take the screws down in. And I was blessed to get these nice zinc coated screws on sale at Home Depot. 5 pounds of screws for only $7. Really good deal. And so I'm dropping those down in, and I'll keep you updated as we go forward. Earlier I mentioned that I was using a 3/8 bit to countersink for screws, and the reason why that I was doing that was because my El Cheapo countersink rig had snapped off, but at that point I was trying to countersink in the harder wood, and I found another one of those El Cheapos. But since MDF is easy to drill into, I think this one will work. So I'm going to abandon use of the 3/8 drill bit for countersinking for now, and I will drill and countersink in the same action. And I know that I can loosen a set screw and put a better bit in there, but I have my doubts of whether I can even get that set screw loosened out of there. But I've got a rig for working with now. Okay, pretty much dead on, same laser measurement of height all across the whole top skin of the torsion box. Screws were added temporarily to hold the backer board in place until the glue dried. Then the screws were removed so that they would not be in the way when thicker, larger screws were used to attach the metal rail to the backer board to hold it to the table. Here I'm detaching the metal rail, which is also sold under the brand names of SuperStrut and Unistrut. I'm removing it from the old table so that I can move it up and install it on the newer table. I used a 9/64 bit to pre-drill for each of the large screws, and I drilled in such a way as that each screw went through the hole in the back of the Unistrut, through the backer board, and then into the X-rib itself. Give maximum holding power and maximum stability. So when I detached my rail from the old table and was getting ready to attach it to the new table, I accidentally dropped the rail. And at that point, it still had the Y EMT conduit rail attached to it, and it hit in such a way as that it broke nearly every one of my rail blocks. And so I just happened to have some blue plastic in my printer at the time and didn't bother with fetching black plastic to replace the broken ones. And so I'm now in the process of inserting the newly printed ones onto the end and then sliding them down to get them into position. And then I'll be reattaching the rail, and you can see where I've drilled and tapped measured holes in the SuperStrut, in the metal strut. And this is a remixed rail block. It lacks the adjustability of the original rail blocks designed by Ryan, but it's designed so that when it fits onto the SuperStrut, that it positions the rail in the right place and has very little stick out off of the super strut. The wing extenders take care of positioning the long belts, provide the tensioners for the long belts, and also provide the end stop surface. The particular screws that I'm using are M5 button head, and they use a 3mm hex tip Allen head driver. Okay, so I marked where I needed to attach to get the rail in the right position, and those markings, I'll need to position them so that they are centered on the X-rib, and I've got one of those markings at every single location. And on the back side, when I originally mounted the super strut onto this generic homogeneous surface, I could put these large bolts anywhere that I wanted to. But now on this torsion box, I have to put them specifically in locations where they hit these X-rails, or at least I'm choosing to. I could possibly do a bolt and nut and fix them just anywhere I wanted to along this OSB, but I'm choosing to use these screws going in and through the OSB and into the ribs. And what that has meant is that occasionally a slot wasn't wide enough and I had to drill out and use a Dremel tool and file to lengthen some of these slots. Some of them, the slot was already in the right location. I put a check mark where I didn't need to drill, check mark. But this one I had to drill and use the Dremel tool to widen the slot. Here I had you just drill, no Dremel work needed, just drill a hole. And here again, had to widen the slot with a combination of drill, Dremel tool, and file. Okay, so I have the new torsion box CNC table installed, and I'm almost ready to put my LowRider back onto it. And I've already got everything set up on that far side with the the rail, and I'm about halfway done with putting together these parts that provide tensioning and provide end stop for the near side. This last one here I need to put together, and these slip inside the ends of the super strut, and there's a screw in there that grabs onto a captured nut inside a shuttle that's a tensioner block, a belt clip that provides adjustable tension for the long belt. All right, we are ready to put the gantry back on. This wonderful new torsion box CNC table is demonstrably flatter. And now it's time to resurface the spoil board, which is next up on my list. And then I'll be ready to go again with my wonderful, amazing, mostly printed CNC LowRider version 3. And here it is, my wonderful new resurfaced spoil board on my wonderful new, amazingly flat torsion box CNC table. I'm going to be able to do so much more with this than I was able to do before, and I hope by sharing the plans for this CNC cut torsion box table, it will help many other makers to take their table performance to the next level and increase their efficiency. If you have made a LowRider but you don't think you can make this table, I want to encourage you that you can. And if you want to make a LowRider and you're thinking that you wouldn't be able to make this table without already having a table like I've done, there are suggestions in both my download page and on the discussion forum for how to bootstrap a table like this. You can throw some MDF onto the floor, a concrete floor in your garage, wherever the widest, flattest floor you have, and you can turn it into a makeshift table and CNC cut your torsion box ribs and spars and be able to make your own table like this. Ryan, the founder of V1 Engineering, has suggestions in his shared plans for a CNC cut table on how to do the legs and bracing. And so I encourage you, don't feel like you can't do this. You absolutely can. And I'm just so thrilled to be to this point. Like I said, we always build to the best of our ability at the time. And I hope this helps all of you to raise your CNC experience to the next level. Hi, this is Doug Joseph with Design 8 Studio. If you like our content, please click like and subscribe. It helps us with the YouTube algorithm. And until the next video, I wish you happy making.